We now know how to find the zeros or the roots of a quadratic function, and actually knowing this is super helpful because here's what we can do. If we think about a quadratic function, ax plus bx plus, or ax squared plus bx plus c, right? And we know it has two zeros, okay? It could be repeated or they could be complex for now, whatever. It's going to have two of them, okay? But if we know the two roots or the two zeros, right, then we can say when x is equal to r1 or, equivalently, x minus r1 is equal to 0, okay? We know that f of r1, if we put in that 0, we get a function value of 0. Same thing with r2. Okay, fine. Okay, and so since we know that one method to find the zeros involves factoring, that means that if um, if we have f of r2 equals 0 or f of r1 equals 0, then x minus r1 and x minus r2 both must be factors, okay? Meaning like x minus r1 times x minus r2 must equal this, but then we do have to include a value a out in front as a scaling, so that, after distributing, we get that same constant or that same leading term, okay, of ax squared. So we have another way to write a quadratic function rather than ax squared plus bx plus c. We have it in this sort of factored form, okay? And actually, this extends to all polynomials via the factor theorem, okay? We'll see this again later on, but it just says that if we know that a number is a 0, okay, then that means it's a factor of the polynomial, okay? And an equivalent statement is shown here. So if we have, certain numbers are roots or zeros, right, of a polynomial, then we just multiply all the factors that have those roots as solutions in there together with a value a in front, and we get the polynomial. That's really nice. Okay, so this other form could be useful. Okay, so here we go. We have a quadratic function, and we want to express it as a product of its factors, and then we want to state the zeros. Okay, so here we go. First thing is, can I factor this? That one, the first one, f, I don't think I can, but how could I find its zeros? Okay, well, I know how to find its zeros. I would have to set it equal to 0 and then find the values of x. Okay, so since it doesn't factor, you could try it. It's not going to work. I'm going to do negative b, which is -4, so negative of negative is positive, plus or minus square root of b squared, so 16, minus 4 times a, which is 4 times a, times c, all over 2a, which is 2, okay? And so x is going to equal 4 plus or minus, and let's see, this is going to be 16 plus 16, so square root of 32 over 2. And if I go ahead and simplify that, that's going to be 4 plus or minus, that'd be 16 times 2, so I can write that as 4 square root 2 all over 2. So this is actually 2 plus or minus 2 square root 2, okay? So I did this backwards. I found the zeros, and if I wanted to find the factored form of this, okay, this would just equal a, which is 1, times x minus r1 times x minus r2, okay? And so in factored form, this would be x minus, and then maybe parentheses will help, 2 plus 2 root 2 times x minus 2 minus 2 root 2, okay? And I can leave it like that. Isn't that lovely? It looks so fun, okay? And you're probably like, Professor Bright, you are a weird person. I know, but you love me, maybe, sometimes. Anyway, for g of x, I'm going to do the same thing. Now this one, let's try playing with this a little bit. I notice that each thing has a common factor of 4 in, so I'm going to factor a 4 out, x squared minus 4x plus 4. Okay, so this is a different one. And inside there, that actually factors. This would be x minus 2 times x minus 2, or I could just write this as 4 times x minus 2 squared. okay? And so what I notice here is that the 2, since if I were to set this equal to 0, right, I could, solve for x and I would get 2, but actually right here, this is telling me that I have a 0 of 2, okay? Or in other words, x equals 2 is a 0 of g of x, okay? So if you're able to factor it, you get the zeros from it very fast, okay? And again, these are just places where it meets the horizontal axis. So that's the big takeaway, okay? If we can write the polynomial as a product of its factors, then the factors themselves are the zeros, the roots, the x-intercepts, okay? All those three things are all the same, all right? So maybe make sure to use that when you're analyze the function to create the graph.